Hello everyone, I welcome you all to Physics Wala, and in this session we are going to discuss the next portion related to our very interesting chapter of organic chemistry, which is basically the concept of hydrocarbons. Now in the previous session we were basically talking about the basic analysis of the structures which are associated with the hydrocarbons. Either that part is related to the conformational analysis of a butane, ethane, or some basic idea about the Newman projection, how you are going to write the molecule in case of Newman projection. Now if I talk about the next part is going to be quite interesting because we were discussing about the cyclohexane part. So definitely in this session we are going to complete the ring flipping of cyclohexane part, and then we are going to start the next portion, which is nothing but the preparation methods of alkenes, alkanes as well as alkynes. Okay, so let's start. If I talk about this entire part, first of all, we are going to complete the conformational analysis related to cyclohexane. Then we are going to discuss about the preparation of alkanes as well as preparation of alkenes. Let's start. If I talk about the first analysis, we know that the actual structure of a cyclohexane actually looks like a chair form. So this is a chair form. This entire part is a chair form. And I told you in this particular chair form, you can see some bonds which are above or below the plane. These bonds are basically your axial bonds. So you can say axial, 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 axial as well as axial. It means in cyclohexane, 6 type of bonds are axial bonds. In case of next part, you can see some bonds which are present on the equator. So those are known as equatorial bond. That part we already discussed in the previous session. If I talk about the equatorial bond, you can see these type of bonds which are present on the equator of the molecule. Those are equatorial bonds. So basically in the chair form, you can see that this entire part is going to look like this. Now if I talk about the actual analysis, you can say that in case of Newman projection, you can write down the molecule just like this. You can write down the molecule just like this. So let's say this is the front carbon, they are connected with each other. Back carbons, they are connected with each other. So if I talk about the next part, this must be H, this must be H, and this must be H as well as H. So I can write down the projection here, and if I talk about the next part, you can see the projection like this. The projection like this. Now first of all, if you look clearly in this particular situation, the electron pairs are far apart from each other. The electron pairs are far apart from each other. It means in this particular case, you can see that torsional strain is minimum. First of all, you can see that the torsional strain is minimum first of all. Next part, if I talk about the van der Waals strain, because these two groups are opposite to each other, one part is upside and next part is downward side, you can say in this case that steric strain is also minimum in this situation, is a minimum in this situation. So you can say that this entire form, which is the chair form, is highly stable form. It is a highly stable form. Now what about the next part? Let's say I am talking about the boat formation. Let's say I am talking about the boat formation. In that case, the actual structure actually looks like this. Now what happens if you see the entire molecule from this side? You can see front carbon, you can see back carbon, you can see front carbon, you can see back carbon. So if I draw this structure, it will look like this. So this is front carbon, this is back carbon, this is front carbon, and this is back carbon, let's say. Now you can see that both front carbon and back carbon, this front carbon and this front carbon, this front carbon and this front carbon, they are connected with the CH2 on the upward side. So they are connected with the CH2 on the upward side. Now same case with these two carbons, they are also connected with CH2 on the upward side. So you can see in this particular situation, it looks like this. It looks like this. If that is the scenario, remaining bonds are like this, remaining bonds are like this. So in this situation also, you can see remaining bonds will be like this. They are in front of each other. They are in front of each other. Although remaining groups are definitely H, 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 and hydrogen only. But you can see in this particular situation that this actually looks like a eclipse type of form. This actually looks like a staggered form. This looks like a staggered form, but this actually looks like an eclipsed form. So there is some issue with this entire part. As you can see in this particular case, first of all, torsional strain will be there. Definitely torsional strain will be there. You can see, because each electron pair is in front of each other, definitely they are going to repel. And you can see these two CH2 groups, they are very close to each other. These two CH2 groups are very close to each other. So you can see in this particular situation, steric strain is also there. Both are maximum. Both are maximum. So this structure, which is boat form, is actually highly unstable. This form will be highly unstable. Now, if I talk about the entire analysis, you can see two hydrogens which are close to each other in this structure, This type of hydrogen, they are known as flagpole hydrogens. So in this case, you can see we have a 6 equatorial and 6 axial parts. In this situation, you can only see 4 axial bonds. You can see 6 equatorial bonds. And you can see 2 flagpole interactions. So two flagpole bonds are there like this one and this one. These are flagpole. Okay. I hope this part is clear. I hope this entire part is clear. In this situation, you can see only 6 equatorial as well as a 6 axial part. Okay. Now, if I talk about the next analysis, like how to flip the ring, what is the actual analysis regarding the flipping of a particular cyclohexane ring? So it's very easy. It's actually very easy. So if I talk about the same type of curve, whatever we have drawn for the previous portion, let's say we have this part, and this will be the maximum energy, let's say, and say okay, this will be the minimum energy, let's say. Now, what are the forms which are going to exist in this particular case? Definitely we are talking about the energy, and in this case we are talking about different type of forms. First of all, we have to understand what type of forms are going to exist in this particular case. I told you in the previous session also that in this particular situation, you can see first of all we have, let's say if I talk about the structural analysis, I can say that you may have you are starting with the chair form. Let's say eventually it's going to convert into the next part, which is, let's say, this is chair form. It's going to be converted into half chair form. So let's say we have this situation similar, and now it becomes flat. Like this. So this becomes half chair. Eventually what happens, that it's going to be converted into twisted chair. Okay. Twisted boat is like you have boat, but these two corners, the corners of the boat, they are not front of each other. One is slightly away from you and next is towards you. It's like a twisted boat. Okay. So if I draw correctly, it will look like something like this. Yes, it will look something like this. Okay, a twisted boat. Then eventually it's going to be converted into proper boat form. This is a proper boat form. Now if I talk about the next part, Again, it's going to be converted into twisted boat form, and eventually it's going to be converted into it's supposed to be again half chair. I know my drawing is not that good, but it will work. It will work. And eventually it will look like this, which is again a chair form. Now, what happens in the entire analysis? This is the axial part H1 and this is the equatorial part H2. What happens in this particular situation? H1 is axial and this one is equatorial, H2 is equatorial. What happens? You can see that H2 becomes axial and H1 becomes equatorial. So that's how the flipping is going to work. Axial bonds are going to be converted into equatorial one and equatorial bonds are going to be converted into axial one. That is the basic analysis. I hope this entire part is clear. Just have a look at it. Just try to draw the entire analysis. Now we are going to figure out what's going to happen when we talk about the energy diagram analysis in this particular situation. Okay, so first of all, if I talk about this curve, the least energy part, this must be, let's say, E minimum. Let's say we are starting from this part and this must be E maximum. Okay, and in this case we are talking about the ring flipping. So we always start with the boat form. Boat form is going to convert into half chair, which is highly unstable. So then we have half chair. This entire part is going to be converted into some form. So it actually looks like this. It starts from this entire part. It will eventually increase. Then it's going to decrease. Then eventually it's going to increase. Then it's going to decrease. Then eventually it's going to increase and then it's going to decrease. This entire part actually looks like this. So this, in this situation we have boat form. In this situation we have sorry, not boat form, chair form is having minimum energy. So this must be the chair form. So you can see we always starts with this chair form. Then it becomes half chair. This becomes half chair and then we have twisted boat. In twisted boat, because the flagpole interaction is not there, they are not in contact with each other, they are away from you and towards you. So it means flagpole interaction is not there, that's why it is slightly stable. It is slightly stable. So if I talk about the structure, it actually looks like this. This is the twisted boat. Then we have a proper boat. Then we have a proper boat. And then we have again twisted boat. Then we have half chair. And last part will be your chair form. That will be your chair form. And that's how this entire part is going to takes place. Just note down this important portion. Just note down this important portion. Okay, I hope this entire part is clear. Now there may be like one chance that somebody is going to ask you about the monosubstituted cyclohexane ring. So if somebody asks you about the monosubstituted cyclohexane, so what is going to happen in this particular situation? There might be a chance that, let's say, I have the situation that if I talk about this part which is a CH3, if this part is present on the axial position, there might be a chance that this entire part is going to be present on the equatorial position. Now, which one will be the most stable conformer in this particular situation? So, always remember, in this case, the CH3 is present on the axial position, and in this case, it is present in the equatorial position. What happens in this particular situation? If you look clearly, so we have a C, H, H as well as H. This is the situation. Now, with respect to this carbon, 1, 2, 3, this position is a third position, as well as if I talk about this part, you can see 1, 2, 3. This position is also third position. You can see this hydrogen or this electron pair of hydrogen is going to interact with this hydrogen as well as this hydrogen. You can see the interaction is going to take place between these two parts. You can see the interaction is going to take place between these two parts, and you can see that we have 1,3 diaxial repulsion. We have a situation which is known as 1,3 diaxial repulsion because of the presence of a bulky group. You can say presence of bulky group on axial position. Just because of the presence of bulky group on the axial position, their electron pairs are going to interact with this hydrogen as well as this hydrogen, which are present on the third position, third carbon. Okay, that part is known as 1,3 diaxial repulsion, and this part is a maximum when we are talking about the entire part, when it is present in the axial position. When it is present in the equatorial position, you can see when this entire part is present on the equatorial position, it means you have only hydrogen. So with respect to this hydrogen as well as this hydrogen, this interaction is very less because this hydrogen is already small in size. In this case, you can see no 1,3 diaxial repulsion. If it is not there, then you can clearly say that we have achieved the goal, that 1,3 diaxial repulsion is not there, and equatorial, like the side substrate which is present on the equatorial part, will be more stable. So you can say this part, this entire conformation is more stable, while this entire part will be less stable. Okay, so that is all for the analysis of our first portion, which is conformational analysis of cyclohexane. Just have a look at it, because now we are going to start the preparation methods of alkane first. Okay, so let's start the next portion, which is quite interesting. Because if you know the preparation methods of alkanes, you actually know most of the reactions related to the derivatives of hydrocarbons. Okay, so we are starting with the first portion, which is preparation of alkanes. Okay. So first of all, the idea is very easy. You can prepare this entire part from alkene or alkyne. If you have a alkene having double bond or alkyne having triple bond, you can actually convert the entire part of alkene and alkyne into alkane by simply reduction. So you can say the process is going to be reduction. Okay, you have to reduce the entire part to convert alkene or alkyne into alkanes, and that part is actually known as hydrogenation reaction. That part is known as hydrogenation. So hydrogenation of alkene or alkyne. Okay, so what happens? So let's say I have a particular alkene R CH double bond CH2. So what I'm going to use? I'm going to use H2 definitely. Now in presence of a particular catalyst, it may be nickel, it may be platinum, it may be palladium, that depends upon the condition, as well as I can use a specific temperature, let's say 25 degrees Celsius, and I can convert this alkene into alkane. So it becomes RCH2 CH3, which is a very simple reaction. It may be possible that I'm using RC triple bond CH like this, and again I'm using the same type of conditions. I can convert this entire part again into RCH2 CH3. Definitely, definitely. So in this particular scenario, you know that H2 is used for the hydrogenation, and this entire reaction actually takes place in presence of either nickel or palladium or platinum or rhodium. They are actually catalyst. They are actually catalyst. Now remember, this entire reaction has, like, it is divided into two parts. It may be homogeneous in nature, or it may be heterogeneous in nature. It may be homogeneous or it may be heterogeneous in nature. Homogeneous means, in this case, you can see that we have reactant and catalyst. They are present in same phase or same state, you can say, when they are present in the same state. But in this case, you know, when the reactant and your catalyst, they are present in different phase, then we are talking about the reaction which is heterogeneous in nature. Generally, this type of reaction is heterogeneous in nature. This entire part is heterogeneous catalysis, because in this particular scenario, nickel, palladium or platinum, whatever we are using, they are present in the solid state. But I can use one part which is rhodium catalyst. I can make an organic compound, soluble organic compound of rhodium, which can act as a catalyst, and that part will be actually your homogeneous catalysis. Okay, I hope this part is clear. So first reaction is very easy, that you can prepare alkanes by simply reducing alkenes and alkynes in presence of hydrogen. That part is actually known as hydrogenation reaction. Okay, I hope this entire part is clear. You must have seen this type of reaction in your class 10th also. Then we are when you are converting vanaspati oil into vanaspati ghee, like that. So unsaturated compound can be easily converted into saturated compound using nickel as a catalyst at room temperature with the help of hydrogen gas. Okay, so that is the simple analysis of the entire reaction. Now second part is quite interesting. In this case, if I talk about the second part, I am using from alkyl halide. I am using alkyl halide. What is alkyl halide? The compound which contains alkyl group as well as halogen group. For example, we have CH3, CH2, Cl, alkyl halide. We have, let's say, CH3, CH2, Br. We have CH3, Cl, we have CH3, C, CH3, CH, Cl, this type of compounds. All these type of compounds are basically known as your alkyl halides. So from alkyl halides, there are numerous methods. There are n number of methods by which you can prepare this entire formation. Now in this particular scenario, I'm talking about the first part, which is from organometallic compound. As the name suggests itself, organometallic compounds means we have an organic part as well as we have an metallic part. Those compounds are basically known as organometallic compounds. So this scenario corresponds to different type of important reactions. In this case, you must have seen Franklin reaction, you can see Wood's reaction. These reactions are very common in the entire part. So first of all, from the organometallic compounds, you can prepare simple alkanes, and the starting point will be alkyl halide. So in this scenario, I'm talking about the from organometallic compound, the first reaction will be Wood's reaction. The first reaction will be the Wood's reaction. What happens? So let's say I have Rx. It means I have alkyl halide. I am going to react it with sodium in presence of dry ether. Finally, what happens? It's going to create something like RR plus NaX will be removed. Now, in this particular scenario, I'm starting with a particular alkyl chain, and it actually regenerates itself. So, in this particular reaction, you can see there is a increment. There is an increment in chain size in final product. So whenever you want a like more larger size of the chain, you can use this entire part. Now what is the property of this alkyl halide? It must be 1 degree or 2 degree. It must be 1 degree or 2 degree. What is the meaning of 1 degree and 2 degree? So let's say I have the situation that this carbon which is connected with halogen, it is only connected to one hydrogen. So let's say this is the situation, and this entire part is connected with two other hydrogens. So the carbon which is attached with halogen is connected with one carbon only. It means we are talking about the 1 degree alkyl halide. If I talk about the next part, let's say this carbon which is connected to halogen is now connected with the two carbons. So you can say this must be 2 degree, and 3 degree is now clear to you. It means let's say I have this carbon which is connected to halogen. This is connected to 3 other carbon atoms. It means we are talking about 3 degree alkyl halide. So always remember, only 1 degree and 2 degree, they are going to give this entire part. 3 degree is not going to be there. In case of 3 degree, the entire reaction is slightly different. Let's try to decode it. Let's try to decode this part first. So first of all, what is the mechanism? So there are two proposed mechanisms in this case. We are not sure which one they are going to follow, but both the mechanisms are capable to answer the basic analysis or basic formation of simple alkanes. What happens? Let's say I'm starting with this Rx. Okay, I'm starting with this Rx, or let's say I'm starting with Na, 2 sodium. Definitely sodium has a tendency to actually lose its electrons. It becomes Na positive, 2 Na positive, and it's going to liberate 2 electrons. First part. Then what happens, that we have Rx type of bond. They are going to actually accept 2 electrons, and eventually they are going to convert into R negative as well as X negative. This X negative is going to combine with Na positive, that becomes NaX. Now this R negative is going to attack on another Rx unit. So it's going to attack on this part. This is going to be liberated, and this part is nothing but substitution. So that's how this R is going to form. Another X negative is there. X negative was earlier formed. Now one more X negative is there. So they are going to combine with the 2 Na positive. So 2 Na positive plus 2x negative becomes 2 NaX. Always remember, this entire reaction is going to take place in a dry ether, because in presence of water or hydrogen, this R negative which is formed in the reaction is going to attack on that H positive, and eventually the reaction stops. So that's why we generally use a dry ether medium which is away from water or any type of moisture. Okay, so this mechanism is according to the ionic part. This is ionic type mechanism. There is one more mechanism, you can say free radical type mechanism, which is going to work in this particular scenario. If I may write here, I can say that we have Na, which is going to be converted into Na positive plus X negative, sorry, Na positive plus electron. It's going to be converted into Na positive plus electron. Now what happens that we have Rx, and eventually what happens that they are going to be converted into their free radical. This free radical is going to combine with the electron. It becomes R free radical as well as X negative, because this X, whatever one electron is going to have, is going to combine with this electron and it becomes X negative. Now this R free radical is going to attack on the next Rx part. It's going to connect on this part and it's going to be liberated, and eventually you can see there will be a formation of R and R. That must be the ionic form, free radical type mechanism. Okay, so I hope this entire part is clear. Just note down this important point. Just note down this important point. Okay. Okay. Now, if I talk about the same type of analysis with respect to organometallic compounds, there are different type of processes which you can use for the formation of your alkyl halide, I can say. You can start with the alkyl halide and you can form different type of compounds in this particular scenario. If I talk about the next type of reaction, I can simply say that must be, you must have seen that reaction. It's a very interesting reaction. So let's say I'm starting with again Rx part. It's going to combine with first of all lithium and it converts into RLi, alkyl lithium. It becomes alkyl lithium. When this entire part is going to combine with CuI2, this part becomes R2CuLi, alkyl lithium copper. It becomes alkyl lithium copper. Now this entire part, when comes in contact with this Rx, it forms again your simple alkane. This reaction is actually known as Core house synthesis. This entire part is actually known as the Core house synthesis. Okay, so these type of reactions we are going to work upon, like how to predict the products in each type of reaction. Trust me, the preparation method of the entire part is very interesting. Okay, so we have discussed the entire part related to the basic analysis of conformational analysis part with respect to alkane, with respect to cycloalkanes, and we discussed about the first preparation method related to simple alkanes. In the next class, we are going to cover the rest of the part, which is preparation method of alkenes as well as alkynes also, and what are the important type of reactions with respect to each and every part. Okay, so I hope the entire part is clear to everyone. That's all from my side. Thank you so much.